So next I wanted to talk about applications, real-life applications of trig ratios. And I'm using this new method to record, so we'll see how it goes. But I'm going to start with, in this document, number 9. I'm going to use this as an example, and then as we go through, the rest of the problems that we don't do are going to be for your homework. So for number 9, it says a ladder is leaning against the side of a house and forms a 65-degree angle with the ground. The foot of the ladder is 8 feet from the house. Find the length of the ladder. First thing we want to do, as usual, is to draw a picture. Anytime we do trig ratio problems, we need a right triangle. So there's probably some sort of right triangle in this problem. So it says there's a ladder leaning against the side of a house. So let's say this is my ladder, and we'll pretend this is the house. It says it forms a 65-degree angle with the ground. So here's the ground, and here's 65 degrees. Here's my right angle. The foot of the ladder is 8 feet from the house, so that would mean this is 8 feet right here. Find the length of the ladder. So the length of the ladder would be, if this is my ladder right here, I'll call this x since that's what we're trying to find. Well, once we have the triangle set up, this is basically like one of our problems where we have a right triangle and we're solving for x. So if this is my angle at 65 degrees, that means this 8 here is my adjacent side, and the x side would be my hypotenuse. So adjacent and hypotenuse would mean I'm using cosine. So setting up my equation, we're going to do cosine of 65 degrees equals adjacent over hypotenuse. So then solving from there, I would just need to multiply both sides by x. That way I don't have x on the bottom anymore. And then I end up with x cosine 65 degrees equals 8. So let's divide both sides by cosine of 65. So 8 divided by the cosine of 65 degrees in the calculator ends up with 18.9296, but if we're doing 3 decimal places, it'll be 18.930. And that was in feet. So our ladder is 18.93 feet long. That's basically what you want to do for each problem. Draw the picture, then use trig ratios to solve an equation. So let's look at number 10 next. A lighthouse built at sea level is 150 feet high. From its top, the angle of depression of a buoy is 25 degrees. Find the distance from the buoy to the foot of the lighthouse. So one thing I want to talk about is that angle of depression. Angle of depression, it sounds sad because, depressed, but it just means you're looking down. So if it says there's a lighthouse, I'm going to draw a lighthouse. I don't know what lighthouses look like. It says it's 150 feet high, though. And then we're at the top. It says front of its top. The angle of depression of a buoy is 25 degrees. So that means, let's say we're at the top part of this lighthouse. If we look down, so if I looked straight out, it would make like a straight line this way. Angle of depression means I'm looking down, and this angle is 25 degrees. So that's what an angle of depression is. It says we're looking down and we see a buoy in the ocean. So I don't know what that looks like either. Nothing I can draw nicely. We'll just pretend that's it right there. So then find the distance from the buoy to the foot of the lighthouse. So we are looking for this distance here. Okay, which means this is our right angle. Currently, we don't have any angles within, inside our triangle, though. But if we know this angle of depression is 25 degrees, this line of sight, where my dotted line is, all the way to the lighthouse, that should add up to 90 degrees. So I can figure out this inside angle of the triangle by subtracting 90 by 25 to get me 65. So that'll be my angle for inside the triangle. Okay, from there I have my 65 degrees, I have an opposite side, that's the one I'm solving for x, and then I also have an adjacent side, so that's 150, the height of the house. So opposite and adjacent would mean I would use tangent of 65 degrees equals opposite over adjacent. Okay, so it looks like I can just multiply both sides by 150. And then when I multiply that out, I get 321.676. And again, I think this is in feet. Okay, so there's that one. Number 11 is the one I want to look at next. So this time, a surveyor is 100 meters from a bridge. So we've got a person 100 meters from a bridge. We'll just pretend this is the person, and the bridge is like here somewhere. So 100 feet, or 100 meters. The angle of elevation would be you looking up. So if this was you and I'm looking up, they said that angle was 35 degrees. The surveyor's instrument is 1.45 meters above the ground. Find the height of the bridge. Okay, so awkward. This, like where you are with your instrument, is 1.45 meters above the ground. So if we can figure out this length here, its total height would have to include this part where it's like slightly above the ground. So if we can figure out this height right here, we can just add that 1.45 from how tall the instrument was, and that'll give us the total height of the bridge. So to figure out, we'll call it x. Then I just need, that's my opposite side from the 35 degrees. 100 is an adjacent, so that would be tangent again. So tangent of 35 equals x over 100. Multiply both sides by 100. I would get 70.021. So that's the height of x right now, but we need like that little bit that's added but from the instrument. So plus 1.45 would give me 71.471 meters. Okay, I'm not going to do number 12 because it's actually really similar. But I wanted to look down at number 13 because that one's slightly different. So in a parking garage, each level is 20 feet apart. Each ramp to a level is 130 feet long. Okay, so imagine this parking garage with me. You know how like parking garages have multiple levels? So let's say here's 2 levels of the parking garage. Also, I don't know if you've noticed, my pen is rainbow. I thought it was amazing, so that's why I'm using it. Each ramp to a level is 130 feet long. So there's like ramps that you drive on to get to the next level. Ugh, poorly drawn. Okay, but they're saying that's 130, and we'll pretend it's straight because, yeah. Find the measure of elevation for each ramp. Oh, measure of elevation is now talking about an angle. So we're basically trying to figure out like this angle right here. What degrees is that? So we have the 130 labeled. We also need each level is 20 feet apart. So 20 feet apart would be talking about the height right here. So now, rather than them giving us an angle, we have to solve for it. So if x is what we're trying to figure out, that would still be our angle of focus. The 2 sides we're given is an opposite and a hypotenuse. So I guess that would be a sine of x, since that's our angle that we don't know, equals opposite over hypotenuse. Okay, so think back a little bit to your good old geometry days. If we need x by itself, we need to get rid of the sine. To do that, it was the inverse sine. So if you do inverse sine of both sides, that's what got rid of sine. So doing that, that button is like above the sign button in your calculator, so you might have to do like second and then sign. And then you can straight up type in that fraction as 20 and then do the divide sign and 130. That gives us 8.850 if we round to 3 decimal places. So the angle there should be almost 9 degrees, which kind of makes sense. It's not like you want a super steep ramp when you're trying to drive. Okay, that's all the applications that I wanted to talk about. So numbers 14 through 17 are what you're going to do for homework.